represent SO2 equivariant reinforcement learning. Many error problems are embedded in SE2 space. In this block pushing task, for example, the robot end effector and block can be both expressed in the form of an SE2 pose. As such, these problems are often symmetric over group actions of SE2, such as translation and rotation. For example, suppose a robot pushes a block into a new resulting state. If a rotation G is applied to both the state of the block and the pose of the pushing action, then the outcome will be a rotated version of the resulting state. This is a symmetry of the transition function that can be used to structure policy learning. In particular, the transition function in this problem satisfies an invariant equation. When the rotation G is applied to both the state and the action, the transition probability won't change. Similar invariant property applies to the reward function. In this work, we leverage such symmetry to improve the sample efficiency in reinforcement learning. We first implement an Equivariant Actor function pi. When the state is rotated, the output action of pi would equal to the output action of the original state, but with the xy vector rotated. Formally, the actor can be written as an SO2 equivariant function. Here, G is an element of SO2. Applying the rotation G to the state S, then passing GS through pi, will equal to passing S through pi, then applying the rotation G. We further implement an invariant critic function Q. When the state and action are rotated by the same amount, the output of Q remains unchanged. Formally, the critic can be written as an SO2 invariant function. We implement the equivariant structure using weight sharing. By injecting such equivariant property in this actor and the critic, our equivariant version of SEC significantly improved the sample efficiency. This example shows a comparison of conventional SEC and equivariant SEC in the door opening task. Equivariant SEC learns to solve the task after around 1,000 training steps, whereas the conventional SEC only reaches a 20% success rate. We demonstrate the performance of our method in 6 different tasks. In all cases, our equivariant approach shown in blue dramatically outperforms competing baselines.